Hello, I am Bret. This is my show. This is the internet live, unless you're not watching it live. And you're here to ask questions. That's your responsibility. You have a job today. We do this every Thursday. I'm on here talking to the internet on a Thursday of every week for the last 3 or 4 years. So if you're new to this, welcome. Thanks for joining. Today I'm excited. I got a good friend on, Nirmal. We're going to get into a bunch of cool Kubernetes stuff. So I can't wait to get into it. But I have to tell you about the Patreons. So check out my Patreon page. This is member supported. So there's no ads today. I'm not promoting anyone else's stuff in terms of someone paying me. There's no ads because it's member supported. And thank you to you patrons that do that. I appreciate you. So you can join for free. Just click the little follow button and you get a weekly email of the open source I'm making, the course updates, who's going to be on the live show, what's on the podcast this week, all that stuff we're creating. If you would like to be on the high fivers or one of the benefit package levels of the membership, we're doing our high fiver. That's a monthly hangout where we all get on the Discord server. We bring our code, infrastructure as code. We just talk about the projects we're working on, and we do that once a month. That is next week. So if you want to be a part of that and get on our Discord server, we just broke 10,000 people. I'm very excited about that number. Unfortunately, there's not 10,000 people all hanging out answering questions, but there's people in there every day learning containers, learning DevOps, and there's a lot of people helping out, and I'm really excited about the community that's growing there. So if you want to be a part of that, we're going to be on Discord next week. Join the high fivers right there. For $5, you get to hang out, buy me a coffee. I appreciate it. Thank you. All right, let's get to it. Nirmal Mehta, what's up?
What's up? How's it going, Bret? Thanks for having me on your show. I'm Nirmal. I'm a principal specialist solution architect at AWS, and it's great to be back here. It's been a little while. It's been
a Docker captain.
And a Docker captain, and a good friend, and a Patreon supporter of you, and a high fiver.
And a East Coaster. East Coast?
And yep. Mid-Atlantic-er.
Mid-Atlantic. We're hours apart, but we never see each other. We have to go to other cities to conferences to actually hang out.
I know.
It's weird.
I don't think I've ever hung out with you in the actual states that we are in. I've only hung out with you in different time zones.
We did do one in DC. We did a DC thing. Docker used to have a security government thing in DC, and we have pictures in DC, which is technically not a state, but it's right next to Virginia. Well, thanks everyone for joining. We're going to be silly this hour because we just like to have fun. But Nirmal's here to show off some tools, and let's talk about your job. So you haven't always been at AWS,
correct?
And we were just talking before the show. You basically get to help customers adopt Kubernetes on AWS.
Yeah,
is that right?
Yeah. So changed jobs last year. So now I'm at AWS, and I'm helping support the EKS team. So I'm a principal specialist solution architect in our containers team, and focused on helping customers adopt Kubernetes and EKS and all things containers, and helping them solve amazing problems on large scale infrastructure. And I'm super excited to be on your show today to talk about an open source project that AWS founded and spearheaded called Carpenter today. But before we get into that, you got any other questions for me, Bret?
Well, we could spend this whole hour just talking about random Docker stuff. Like before the show, we were talking about, hey, have you tried this tool? Hey, have you tried this tool? Hey, have you tried this tool? So we could just mention those real quick for people. Rapid fire.
Sure.
What is a tool that? So you were talking about Lens. We're going to show off Lens today, but
I'll be showing Lens today. Yeah.
Anything else tools that you?
Well, you were talking about making your command line even more prettier than it is today, or than mine is with what was that, Starship? Something like that.
So let me just show that real quick for people. We haven't really talked about Starship on the show, but I see it everywhere now. So if you see really fancy command prompts, where Git's already in there, there's a bunch of different colors. You can see the branch name. You can I guess that's a tag. I guess that red thing on the right is the tag. I'm not actually sure what that is. I love the fact that it automatically includes the time the command took to run. It's just it's all in like a Rust binary. So you just download it. Super easy to use. So they have an install script. It works on every OS as far as I know, and that leads me to I have this page on my website, bretfisher.com/shell. And I keep that up to date with all of my shell tools, my modifications for the shell. And
so some people like, making, their cars look really nice and detailing and adding accessories to like vehicles, and other people like to collect different art. I think, Bret, you are a connoisseur of Linux shells. You're constantly adapting and refining your user experience in the shell, and your blog post that you keep up to date is awesome. It's what I followed to make my shell look really nice today for demos. So thank you for that, Bret. Thank you from the community for all this information.
I think like many people, I just selfishly wrote a blog post because I needed a reference for my own purposes because I'm on different machines all the time, and people kept asking me, like, what, if you do a course or a conference talk and you have something in your shell, people will ask you about it. Yeah. And I would always be like, I don't have that link handy, or I don't know. That's a thing, and it's hidden in the documentation. So I just had to make this reference for everyone. I honestly, we were talking about before the show, this is a total distraction for a second, but how that the workflow has changed, and I find myself using shells less and less. I'm not having to Vim on a server much anymore because we're doing everything declarative, and we're using automation to push things to servers, and we're replacing servers all the time. So we don't want them to be snowflakes, and we don't want to change them by hand. So I rarely need to do shells into servers, much less edit files on servers anymore. It's just kind of slowly died away. And then we got all these other tools that replace the need for a shell. VS Code has fabulous extensions. I was talking, like, Docker has a GUI that's getting better and better all the time. We've got Lens for Kubernetes. And so even though I know the command line, I continue to find myself just using GUIs more and more, as much as I hate to say that, because I know that there's this underlying elite attitude of no, everything's got to be shell. I need K9S, I need Vim, I need Tmux, I need all the things in my shell. But I just don't do it as much anymore. I think
the through thread is there's a lot more different options out there. So everyone has something that they are familiar with to use to work with their environments now, which is great for accessibility. For the shell command line connoisseur, there's tons of awesome tooling nowadays. For the folks that are maybe not as comfortable or want a user interface, or because of accessibility needs need a user interface, there's awesome tooling these days. So it's getting better and better. I think we're in the golden era of development environments and bespoke tooling, I think.
Right. Sysadmin and dev focused GUI tooling that's not PHP MyAdmin that you have to install on every PHP server, or MySQL admin. Was it PHP MySQL admin or whatever? I can't remember what. Yeah, I just remember I used to use that 15 years ago. But we have all these wonderful tools now, and the shell's great. But in fact, I think even in that sweet shell list, there's ET, which is this Mosh and SSH replacement that I have learned to love. It's great from an iPad. It works fantastic, and it basically is if you've ever used Mosh allows you to use UDP for your SSH connection so that they don't disconnect every time you close your laptop lid or go to sleep. But the negative of that is it doesn't have history. So then you have to do this whole thing with Mosh and Tmux, and it gets really complicated really fast if you want to be able to scroll back while also having connectionless connections. And so Eternal Terminal ET is now a superset of all that and does it all. I think it does require a special port, a high port. But anyway, that's now if you want to do your work from an iPad, that's the way to do it now, is to get the Blink shell, which is the amazing Apple Store app that is an the best shell for iPad and iOS and all that. But we could have a whole show on this, which I think we've had. We probably need to do an annual show. It's not while we're here.
We'll need to put a pin in that one.
I know. So for people in chat, throw all your favorite or new terminal programs in the chat so that we have a list of everyone's, because I don't know it all, right? Like, and I'm certainly opinionated. So there's lots of good tools that I just won't use because I don't like one thing about it, including all of like the terminal GUI replacements out there now. There's like so many of these things that are trying to reinvent the terminal GUI, and every one of them, in my case, like falls down within 20 minutes and doesn't do a thing, that I expect it to do. And then I'm like, okay, screw that tool, and I go back to iTerm or Mac Terminal or whatever. Throw your stuff in there, people, so we can all check out your cool tools. Because like the way I learned about Starship was someone on this show mentioned it, and I had to go check it out, and then now I use it every day.
Cool. So I'm not here to talk about shells, even though we could. By the way, I would love to, maybe come back for that show, and we can kick the tires on some of these new tools that people will put in the chat. So let me know when you end up doing that. I'm here to talk about Kubernetes cluster scaling, autoscaling. Yes. And that's a topic. I think we were talking a couple days ago how this topic is kind of folks that are using Kubernetes, they might not be hitting like the autoscaling or the cluster scaling kind of issue yet, but folks need, if you're in that stage, you need to be aware of what options are out there to automatically scale out the cluster and the nodes that are supporting your Kubernetes cluster. And that's one of those options is called Carpenter. And that's what we'll be talking about today. But that's not necessarily something that is if it's your first day running Kubernetes, you're kicking the tires on it. You're probably not thinking about that just yet, but this will be a good show for you to reference later on your Kubernetes journey once you hit to some of those scaling issues to think about. And then if you are running like an EKS cluster or multiple clusters, and you're starting to utilize a lot of your resources and you want to improve your operations of that cluster and start to scale it out, this is super relevant for that group as well. So I'm kind of trying to address two different groups of Kubernetes users right now, like the early stage where you want to keep this in mind, and then folks that are potentially about to hit some of the scale, the operations of scaling out and maintaining your cluster and making sure the right compute resources are there for the workloads that you're trying to run. So you want to pull up the presentation, Bret, and we can kind of start digging into it.
Yeah, and even before we say that, real quick, for those that are new to autoscaling, it'll be good for us to talk about. We'll talk about during the slides, but there are many types of autoscaling, like you're saying, and what we're going to focus on today is a particular type of autoscaling. But if you're someone who's trying to be completely agile in all your infrastructure and you're super mature in your Kubernetes evolution and all that, you probably are going to end up with at least two different types of autoscaling at the same time, because there's a lot of complexity and there's a lot of problems that you have to solve with autoscaling, not just I have a tool that does it all. And that's a great, it deserves a bunch of course videos, on different types of autoscaling and the pros and cons of each, and the fact that they aren't all competitors to each other. A lot of times it's additive, the different levels of horizontal and vertical and node and pod, and it gets to be a lot. So I'm excited to have some slides. We don't actually normally do slides on this show, but I think in this case, it's actually worthwhile because we need to define the problem that we're trying to solve in this particular case, not all autoscaling in all of the universe, right?
Yeah, absolutely. So very much so. You typically don't have slides on this, but we need some visual aids today in this conversation, just to understand what we're talking about here. And so I'm going to start off talking about what we're not talking about, what Carpenter is not addressing. And so there's generally two or three different types of scaling in the Kubernetes world, right? So the first two are what what you might see on out there if you're starting your Kubernetes journey is horizontal pod autoscaling and vertical pod autoscaling. And this is scaling the actual containers, the pods, right? So horizontal pod autoscaling is just that. It's based on resource, based on triggers and thresholds. You're going to create more pods to meet the demand and the load for that service. So you're going to deploy more pods in a horizontal fashion to load balance that load across the existing compute, the existing Kubernetes compute cluster nodes, right? And then there's another option, which is maybe instead of creating more pods, you adjust the resources that that pod has and you vertically scale that. So maybe giving it more CPU, more memory, more network resources, and you're creating a bigger pod, and to meet the demand. So that's at the pod level. Those are scaling. That's auto scaling at the pod level. That's not what we're going to be talking about today. What we're going to be talking and addressing with Carpenter is what's called cluster auto scaling. So the other part of scaling is actually creating additional compute nodes for those pods to live on and run on. So if you have let's say a 2-node EKS cluster, you have 2 EC2 instances that are available for running your pods and your workloads. And for some reason, you've maxed out the resources on those 2 EC2 instances. You want to automatically have another node EC2 instance spin up based on that threshold. And the classic way right now to do that is using the Kubernetes cluster autoscaler, right? So Amazon has one, AWS has one. It's called the AWS cluster autoscaler. And what it does is it looks at the pending pod queue and it does a API request to the autoscaling group, right? So if you have a managed node group, you have an autoscaling group that's specific to that instance size and that launch template. And it's going to look at the limits, the min and max of that autoscaling group. And it's automatically going to provision another compute node up to that max of that instance type to meet that load. But it has to kind of go through the whole entire ASG process to do that, right? So that's what we're going to be talking about today. Carpenter is a alternate to the cluster autoscaler. So I want to make sure that we're very clear on there's 2 different types of scaling here, and what we're talking about is the cluster autoscaling today.
Yeah, and that's a question Kokjen asked. Does this coexist, or is this intended to be a cluster autoscaler replacement? And you're saying it is a replacement for CAS.
Yeah, so they can. So technically they can coexist, but you have to be careful about race conditions and make sure they're mutually exclusive. But for all intents and purposes for this conversation, it's a replacement. It's an alternate to the cluster autoscaler.
Okay.
So
do you view it as a superset of the CAS functionality?
No.
No?
It's an alternate.
Okay.
It's a different way of doing it.
Okay.
So some of the issues right now with the cluster autoscaler is you're creating autoscaling groups and managed nodes groups based on certain instance types. And that's going to, that's bespoke to the types of workloads that you think are going to be running on that cluster. Well, if you have different types of workloads, then you have to make a decision on either spinning up a new cluster with different types of compute, creating a new managed node group that has specific resources that are tuned to that different type of workload. So say you have like web application workloads, and then you have a machine learning GPU intensive workload. Right now with the cluster autoscaler, that would be different managed node groups. That would be different types of compute, and they'd have different scaling characteristics, and you not necessarily being able to share resources really effectively there. And so as you're growing out your use of Kubernetes, you're going to have this kind of engineering decision or architectural decision on what types of compute do I want, and how much of that compute do I want to match the workloads that I'm going to be running. And with cluster autoscaler, it's kind of granular right now, or not granular. What I'd say, it's not one size fits all. You have to kind of make those trade-offs. So balancing the needs of those workloads and what the compute looks like, you're going to have some wasted compute there, right? So you might have to spin up a new cluster for specific type of workloads, and then you have to manage that cluster separately. So wouldn't it be better if you could have a cluster autoscaler that can match the workload or match the new node and scale up the compute layer to best match the workload that's coming down and what you want to run in the queue. So this kind of heterogeneous workload creates issues around being able to respond with just the ASGs and the cluster autoscaler to these different type of workloads. And another thing is you have to go through the whole entire auto scaling group process to scale up those specific types of nodes, right? So that might take a while to do. And you want to also be able to respond quickly to the different types of workloads that are coming down the pipe. So these are the issues that Carpenter was created to address, which is balancing user utilization, making sure that there's the right type of compute for your workload at the right time in an efficient and cost-effective way, and making sure that that is available when you need it. So Carpenter is an open source project that was released to be able to address these issues and make the promise of Kubernetes real for our Kubernetes customer base and for the EKS customer base. And that's around dynamic groupless node provisioning. So you're no longer stuck to a specific type of instance type and the auto scaling groups. You have automatically a way to choose the right node size and instance type based on the workloads that are in the pipe, and to be able to not lose any of the performance to scale this up as quickly as possible. So I'm going to pause there. Do you have any questions around that, Bret?
So you mentioned a good example would be like you have a cluster that's really all just CPU based workloads, but then you need a special resource type like a GPU node.
Right.
And this is able to add those or to figure that out based on requirements that you put in your deployment. I guess you're putting it in your deployment spec, and then it's able to pick, knowing what's available, it's able to go pick a GPU node, add it to the cluster or whatever it needs, and it doesn't require any additional customization on the part of the like sysadmin, basically the Kubernetes cluster admin. Is that how it works?
Yes. So we'll get into how it works in just a second, but you're getting there, Bret.
Yeah.
There's two main components to it. Carpenter, it runs as a controller, and you give it what's called there's a CRD called a provisioner, and the provisioner is the way that the operations team can specify to Carpenter what type of instances are allowed to be
approved for
provisioned.
use. Yeah.
Approved for use or
provisioning,
provisioned by Carpenter, right? So by default, it's it takes the whole entire catalog of instance types that are available. It's both on demand and spot type instances. So by default, it takes the whole entire catalog, but that might not be what's approved by your organization. So you can use that provisioner to limit the types of instances or types of compute that you want Carpenter to provision. And then the other piece to it is Carpenter takes a look at a lot of different inputs that are in your pod definition or your deployment definition, such as the taints and tolerations, labels, the memory and CPU needs, and all the other kind of aspects of pod scheduling to best match a batch of pods in the unschedulable queue to a resource that's available from the catalog of instance types, and then matches those up at best it's the best it can, and then provisions that as fast as possible to meet that pod. So those are the two kind of components. So it uses the provisioner as the rules for what types of instances to provision, and then it takes a look at the resources that are defined and matches that up as fast as possible and in a cost-effective manner. It's pretty awesome.
Yeah. And the more I got into it with you the other day when we were talking about it, the more I was interested in it, because it does seem to try to capture a lot of the problems that aren't maybe obvious on day one of, I want to do auto scaling of nodes, and then you find out eventually you're like, oh, I need right sizing essentially, and I need some of these other things that are maybe there might be a tool or something out there that already does it, but it's an additional tool. So now you're adding all these other things. So we have some questions I'm going to ask real quick of you before we get into demos.
Yeah, sure. And
is it designed to work with AWS only? I think that's probably going to be the number one question.
Yeah,
we get
so
today.
It's designed to be flexible with to work with other cloud providers, but right now AWS has been implemented. So
Right.
It's PRs are welcome, and I'll share the links to the GitHub project shortly at the end of this show. But PRs are welcome, but right now it's open for all cloud providers, but AWS is the only one implemented. And
it's a pretty great. By the way, it's a pretty. Yeah. I was gonna say it's a pretty great GitHub URL. It's GitHub AWS Carpenter. Like it's not some really long, Kubernetes dash autoscaling dash Carpenter under AWS dash public. Yeah, it's nice, short, easy URL for everyone to remember. I'll put that in the chat for people.
And it's a very active community. There's a lot of participation there, and there's a lot of new features that are coming out. It's an awesome project and an awesome community. So if you like to nerd out on cluster scaling and node provisioning and deep provisioning, feel free to start getting involved in that community.
So thank you for that. The next question, we only have two. So people, by the way, get your questions in early so we can make sure we get to them.
Sure.
Kamajiru asked, can we auto scale control plane nodes?
So the Carpenter is focused mostly on the data plane and the compute nodes right now. So it's not geared toward the control plane nodes.
And I don't know why you would auto scale, maybe vertically. But in my opinion, auto scaling control plane nodes doesn't give you more capacity. Like you have to kind of, like if things are slow in the API, you have to do some research to find out if is it a database issue? Do you need to scale the database node? So
scaling out control plane and creating a highly available, production ready, performant control plane is not easy.
Right.
It's the whole entire reason the EKS exists to handle that. And there is an awesome talk from this past reInvent on deep diving into how EKS works behind the hood, and you can see all the things that AWS does to make sure that the control plane is performant and highly available. So if you are interested in that, I can definitely post the link to that a little bit later, but that's a whole nother world and a whole nother conversation.
Yeah, I mean, it's an interesting question. So it's not a bad one.
No, absolutely
it's simply a question of, like, you might. Okay, so first off, if you're on EKS, you shouldn't have to worry about this, right? Like you have a toggle. You're not implementing control plane yourself manually, and even if you were, you may not even be using container-based control planes. You might have the binaries running on the host natively, so it gets kind of weird. And so I can see how that. And again, I think the reason people need to scale control plane nodes is usually because they got too many pods now, and they need more resources for the control plane resource. So that's like a vertical scaling to me, not a.
And there's also like the perform. That's a.
Yeah.
Let's put a pin in that because that's a great conversation for another show, for sure. But Kubernetes control plane scaling and performance is like a whole beast unto itself. And so Carpenter, this conversation is not geared toward the control plane scaling.
Got it. Conrad saying this reminds me of Mesosphere. All right. So you brought stuff to show off.
I did.
We're not done with the slides. Sorry.
Yeah. No worries. I just want to make sure, because I think we had a quick conversation about this too, about there's two different types of scheduling happening and how the interplay between those are, what the interplay between those two scheduling systems. So what Carpenter addresses here is scaling the cluster nodes, the compute layer. It's not the scheduling decision necessarily. There's an interplay here, but it's not the scheduling decision that Kubernetes does for figuring out where pods are going to be, right? So if there's enough resources in your existing cluster, in your existing capacity, then the pending pods are going to be scheduled to those resources by Kubernetes, right? By the Kubernetes pod scheduler. Good to go.
Right.
It's once you hit the limits of that capacity, then the Kubernetes scheduler is going to transform those pending pods into what's called unschedulable pods, right? And if you've run Kubernetes for any amount of time in a non-autoscaled, non-cluster autoscale way, you're going to hit this issue at some point where you've got too many pods running, and that N+1 pod, that you want to run is going to come back as unschedulable, right? And what that means is there's not enough capacity. Kubernetes can't find a node that, after filtering and scoring the nodes, it's can't find a node to put that pod onto, to assign to that pod. So this is where Carpenter and cluster. So this queue of unschedulable pods is where Carpenter comes in. It takes a look at that queue of unscheduled pods, and it batches up a certain amount of them, and it looks at the resources, the taints, the tolerations, the labels for that batch of pods, and it does a API call to for the AWS provider. It does an API call to the EC2 Fleet API, which sends back a list of instance types that best match the resources that Carpenter determined for that batch of unschedulable pods. Carpenter then selects one of the instances from that and starts to provision it. And that provisioned instance type and that provisioned compute node is going to be the best. It's going to be right-sized to that set of pods that it needs to schedule. And that's the magic here, right? That's the awesomeness here. So you get an automated instance selection and provisioning of a instance type that best matches the unschedulable pods. And then it assigns those pods to that node. And once that node comes up, those pods will get scheduled on there. So there's no auto scaling group involved. It's batch by batch determined what instance is required. So, if you have this one pod in the unschedulable pod queue that needs a GPU and it needs X amount of CPU and memory, it's going to go hit the Fleet API. It's going to come back with, certain instance types. It's going to pick that, provision that node, boom, that pod gets put on there. And then the next unschedulable pod or next 10 unscheduled pods, maybe it's total memory and CPU is, let's say 8 gigs and 2 virtual CPUs. So you only need a really small instance. So the next instance that Carpenter is going to provision might be like a large instance or an extra large instance for just those pods. So it's going to be a heterogeneous mix of instance types that best match the puzzle pieces of pods that are unschedulable. And so you're no longer trying to roughly fit one type of instance type like you do in the cluster autoscaler up to a certain limit. you can mix and match the instance types, and you get the right workload or the right instance type for that workload. It's pretty sweet.
Got it.
So
the questions are coming in fast and furious. So
all right, do we want to do questions now? Yeah,
it's up to you.
Let's take some questions now.
All right, so let me scroll back a little bit. Does Carpenter also scale down?
Yes.
Hi, Raman.
Yes. So I'll be showing this in just a little bit, but okay. Carpenter puts a TTL, allows you to put a TTL, and by default there's a TTL, a time to live, on each of the nodes that it provisions. So by default, I think it's 30 seconds. It could be even lower than that. But what that means is Carpenter is constantly checking whether there's actually pods on a node. And so outside of the daemon sets and like your backend service pods that are getting scheduled on that are on every single node in your cluster, if there's no actual workload pods on that node anymore, after 30 seconds or whatever the TTL is, Carpenter is going to go ahead and cordon off that node and flush it and destroy it. So one of the tricky things with Kubernetes and scaling in general is it's really easy to start provisioning nodes, but it might be hard to like prune them or do some kind of garbage collection. So Carpenter does that. The other thing that you can do is you can also put an expiration on a node. And so that means that you can say like a node is only supposed to live 7 days, and Carpenter will, after 7 days, destroy that node, regardless if there's, even if there's workloads on there. It's going to cordon it off and destroy it. So you can also make sure that your environment is very fresh, right? Or you can kind of do make sure that your instances are constantly being recycled or refreshed for patching or for other operations and maintenance kind of work that you need to do. So it's really awesome. And yes, scaling down and making sure that the cluster is exactly what is needed is part of the Carpenter design. It's pretty sweet.
Yeah. All right. I'm going to ask 2 more questions, then we're going to get back to it. So we for people that are listening or watching, we'll get to your questions. I'm keeping track of them. Is EKS with Carpenter plus Spot instances, can it replace Spot Inst Ocean for EKS for cost optimization? I don't know about Spot Inst Ocean.
I'm not familiar with Spot Ocean, but Carpenter does support Spot instance types, and it does a smart amount of understanding of what the demand. So when it does the Spot API call, it's looking at data on which instance types are least in demand, so that it's by default going to find a Spot instance that has the least amount of potential interruption.
Right. It'll hang around longer.
It'll
hopefully.
Potentially, there's no guarantees there, but like,
right.
It's trying to give you the best, like the most cost effective, least interruption Spot instance in that region. Right. Or how you have it configured, which is really awesome.
And last question, Kokjin asks, so Carpenter doesn't make use of AWS autoscaling groups, let's say, just an API call to launch instances.
Yep, that's correct.
All right.
Yep.
Sweet.
I see some, I think there's some Amazonians in the chat. I think Justin's there. So there might be some other answers there in more detail coming in the questions. So, but we'll do another quick break in a bit to answer some more questions. But let's get back into it. I think there was a question around like installation and usage. So installation, there's a Helm chart. You can do it just through Kubernetes YAML. There's basically just a controller that needs to run somewhere on a node in your cluster. And then the main CRD that controls it, like I mentioned, is a provisioner. And there's an example of a provisioner on the screen right now. And that is the way you specify what types of nodes you want to provision. You want Carpenter provision. So for example, in in this example provisioner, you can see that there's different availability zones and different capacity types, spot and on demand. So this provisioner, if you apply it, will only provision spot and on demand instances in those availability zones. So that's one way to control it. But there's, I don't have enough time to go over all the permutations of a provisioner. There's documentation on all the options, but it's a very flexible platform or very flexible configuration of provisioners. And you can get very fine grained, or you can just go with the defaults, and it kind of does the best practices by default. Here's another provisioner where we're limiting to only specific types of instance types and specific taints. So this is only going to provision nodes for unscheduled pods that match the nvidia.com/GPU is true taint or has a toleration for that. And then it's only going to spin up P3 8x large or 16x large instance types. So any other unscheduled pod, if this was the only provisioner that you had for Carpenter, only other unschedulable pods that don't have this taint are not going to be, Carpenter's not going to do anything for that. So you can have multiple provisioners that are, the best practice is to be mutually exclusive, but you can have different provisioners maybe for different teams of folks that are using that same cluster, maybe different types of workloads that can be very prescriptive to what those teams want or need, or the budgets or the performance profiles. So it's very flexible in that respect.
Real quick, so when we were talking about this the other day, you made a good point, because I was getting confused around how it affects scheduling and the default Kubernetes scheduler, and and you reminded me that it doesn't actually change the scheduler. And so it's a great point to reiterate again, like you were describing, it only affects unschedulable pods, or it only acts in the case of new pods that need to be scheduled if they get unscheduled. So, and you just made that up, or made that point with the GPU stuff. But I just want to reiterate that again, because I think that's a good distinction that I was a little bit confused about at first, around how, when this thing acts and when it doesn't, and it's not replacing the scheduler, right? It's still the default Kubernetes scheduler.
Yeah, there's an interplay, right? So the interplay there is the pods the Kubernetes scheduler is going to look at pending pods and look at the resources and try to fit those pods into the existing resources. But there's no, like, if you had a cluster and you don't have cluster autoscaler and you don't have Carpenter there, Kubernetes is not going to magically know how to talk to AWS,
right,
like EC2, and like spin up a new node for you, or some other infrastructure provisioner. You have to use some kind of controller like cluster autoscaler or Carpenter to scale out the underlying infrastructure. The only thing that Kubernetes scheduler is going to do is like if they can't find a space for that pod, it's going to label it as unschedulable, and that's where that's where Carpenter comes in. It looks at the unschedulable pod queue as its main input.
Nice.
So let's look at this thing. I've been talking so much, and we're hitting time here.
Yeah, man.
This is great conversation. But and I have time to go a little bit over, but
okay.
Let's get into it. Let's see what this looks like.
Let's show some demos since you worked so hard on
them. We have an EKS cluster here. It's pretty straightforward. Has nothing running on it except for some metrics server, core DNS, and it has the Carpenter controller on there, right? So we've got the Carpenter controller doing its thing. And what we're gonna do is, so it just has a default provisioner on there. It's completely blank. I'm gonna find a pod, and we're gonna just deploy it. So let me look at some workloads here. So let's pick a spot workload, right? So this one, let's look at it real quick, and I'll try to not go too fast. But we have here is a deployment where it has the Spot label on it. It just just needs one CPU and 256 megs of RAM. So, very, very tiny. And it has this capacity type Spot on there. And so Carpenter by default has a list of the well-known labels in the Kubernetes world and some well-known like AWS labels, I guess you could say, and capacity type labels. So it already knows, the default provisioner already knows what Spot is for the AWS provisioner. And so this workload type is, I'm telling Carpenter that I want to run this on Spot type instances. And so let's apply it. Spot, right? So let's take a look at our pods here, or our deployment. And this is Lens. So if you haven't seen Lens, it's a neat user interface for your Kubernetes environment. So we've got our Spot instance running here. Woohoo! So
Yay Spot.
Yay Spot. I've got two compute nodes here. Nothing too crazy going on here, but for some reason, I've got some maybe this workload. I've gone viral, right, on Bret's YouTube channel, and all of a sudden I've got this massive load coming in, right? So I've got to scale this up, and let's scale it up to 100. So I'm gonna ask Kubernetes to deploy 100 pods of this Spot instance, or this Spot workload, right? So it's going to go out there and it's going to say, I can't find those two nodes that I have, is not enough space. So it's going to fill up those two nodes really quickly, but I'm going to hit an unschedulable pod queue pretty soon. So, of course, it found did it find enough space in all my pods? Oh no, here we go. So it happened so quickly. Let's scroll back on what happened here. All right. So it's saying, oh no, those two nodes that I had is not enough space. So there's going to be a queue of, let's say, 95 or 90 of those pods that have become unschedulable. So it batched up 100 of those right here. And it looked at, it sent out an API request. Let me see if I can actually find that in the logs. Give me 1 second here. All right, yeah, here we go. So it was the API call, and Carpenter's smart enough to know, hey, these nano instance sizes, we're going to exclude them. They're not going to be enough. And let's take 95 of them. And here's a list of the types of instances from that API call that can fit that workload that I just asked for. See this list right here? So it's like C5D 24x large.
Yeah.
C6I 24x large. So it picked one of those, and then for 5 pods, it batched them up and it says, oh, a C4 2x large or a C6 ID 2x large fits that workload. So it made that API call, got that list back, and it picked an instance size from there, and it automatically started provisioning those nodes for me. So we can see that there's these 2 nodes automatically got provisioned. And that, I don't know if we're keeping time here, but that happened super quick, right? So
right.
These two nodes are up here. Let's take a look at the pods. So I should have tons of pods here, right?
Yeah, they've all been running at least 2 minutes, and
they've been running at least 2 minutes, and all is good. So I would say in about, let's say, 60 seconds or less, Carpenter looked at those batch of 100 pods I just requested, best matched an instance type to that workload, and then provisioned that instance right away. Pretty awesome. Right? And so I now have a heterogeneous instance type environment here with different types of instances that best match what I just requested for.
Yeah,
So
and I love that it
do
didn't
another.
create 100 servers or 50 servers with
Right,
2 pods each. It
right.
it
So
figured
with
out.
cluster,
Yeah.
yeah. So with cluster autoscaler, if those two existing instances, if I had it
Nodes.
so
Yeah.
that those two nodes, if I had an autoscale group that only maxed out at 4 or was only it was only a M5 large instance, right?
Right.
Because
Right.
I'm super cheap, and I maxed it out to no more than 4 instances. Well, it would not have been able to find space for all those 100 pods, right? Because the math doesn't work out. So Carpenter is still giving me the right size here, but it's mixing and matching the instance sizes for that. So let's find another workload. So let's do a GPU one. So let's apply GPU one. So we've got here a pod that needs AMD GPU as its limit. So okay, apply -f GPU AMD. So we've got that deployment going. Awesome. Now I'm going to scale this out. Let's maybe not go so extreme. Boom. Let's see. So first of all, do I even have a GPU instance ready? So you can see here, how many seconds was that? Were you counting, Bret? Like
5.
10 seconds, 20 seconds, right? It automatically found a GPU instance, and it deployed it for that first pod. And then I asked it to scale out. So it's going to start putting those other pods on there. And if it doesn't have enough space, it might scale out another node.
Right. So this gets to we're going to get to some questions, but a very timely question here is, is a node group the same as node pools in Azure? We can add a new node pool and exist in an existing cluster, but with a different configuration for the node. This is from Biker. I think the answer is yes. I don't actually know Azure as well.
Yeah, so I'm not familiar with that concept in Azure. You can have different types of managed node groups associated with an EKS cluster, but those node groups are associated with specific types of instance types and autoscaling groups and specific launch templates. So that might not be the right granularity for, like you don't want to have to figure out a whole another managed node group or autoscale group or whatnot for like one GPU instance that you're trying to or one GPU pod that you're trying to run.
And that's a manual, and that's a manual activity, whereas this is more automated. Yeah,
this is more automated, correct.
And then what you just talked about. Oh, sorry.
Yeah. So what I want to do real quick, I'll trigger this while we keep talking, and we can answer some questions. But there were some questions about getting rid of nodes, right? So let me delete these deployments. I'm not viral anymore. I don't need 100 spot pods anymore. So I'm going to remove
People have moved on. People have moved on to the next thing. This channel is no longer relevant.
I've stopped doing my hot dog, no hot dog machine learning. So let's delete that. And let's take a look at our nodes. So, I've gotten rid of some of the workloads, and we'll see while we're talking here. We'll see if Carpenter starts to scale this down. Hopefully it will.
I have a friend that instead of hot dog, no hot dog, he prefers the Nicolas Cage, not Nicolas Cage. So all of his demos are of some form of Nicolas Cage. For years now, for years, he's just he's hilarious with it. I love it. I want him to do Nicolas Cage demos for the rest of his life.
That sounds amazing.
Yeah. So you let me know when we saw
just lost it. Yeah, one node just disappeared. So some of these others should start disappearing. Oh, there's another one. So it's scaling down automatically.
Now, in this case of scaling down, is it telling the scheduler to essentially reschedule a pod so that it can, or is it waiting until it's true 0 pods on that node?
Yeah. So for the TTL, it's it's when there's no workload pods running, except for the daemon sets, right? Those are always going to be running. So excluding the daemon set pods, if they're like, I just deleted those spot pods, right? So those started to be removed from the cluster. And when there was a node with nothing else except for the daemon sets running on there, then Carpenter's going to start the TTL, the 30-second timer. The other thing that you can configure in Carpenter is you can provision expiration time for a node. So that's a separate timer where it's counting how long the node, it's timing how long the node has been running. So, hours, days, whatever it is. And I could set a 7, like say like an expiration of 7 days. And then regardless of the workloads that are running on there, it's going to remove that node.
So it's going to drain it, right?
It's going to drain it. So that also means that it's going to provision a new node. So if you want to make sure that your nodes are fresh with the latest security patches or latest AMI, or you for some other reason you want to keep your infrastructure, your compute layer fresh, you can put expirations on your node too.
Yeah, that's an excellent point, because I love to point out easy security features of things, because we all are struggling to keep up with security patches and all that. And we are, in this case, we're not talking about, we are still managing these nodes, right? So like if you're using EKS and you're not using Fargate, right? You're still responsible for the nodes they're patching and whatnot. So this is like kind of one of those things, like even if I didn't think I was going to be putting a bunch of new workloads on, or I needed to auto scale my pods, just the refreshing of nodes ability of this is like something that I would do every time.
Yeah, and I honestly, like going back to the beginning of the discussion, one of the promises of Kubernetes and is to be able to take on whatever workloads are coming in, right? So, one thing that Carpenter addresses is before this, you'd have to make architectural decisions like, do I need to spin up a new cluster for that new team that's doing something different than what this existing, like if I have a cluster that's optimized for specific type of workload, let's say Java web apps or something like that. And then this new team gets stood up that's doing like, data analytics.
It was a really great comment you made. No, I'm just kidding.
For data analytics, apparently you really like data analytics.
I do.
There we go. Then you might have to, as your operations team or the people, your SREs, you might have to make a decision. Do I spin up a separate cluster for that team? Do I need to like reconfigure the instance types I have on my existing cluster? How do I adapt to these two different workloads that have different performance characteristics and needs? So Carpenter, one of the promises of Kubernetes is that you should be able to throw at it like all these different types of workloads, and it becomes this like system that can automatically adapt to that. But it doesn't right now. It's getting better. Carpenter allows you to get to more of that state. Does that make sense?
Yeah.
Right. It starts to get closer to that promise. Right. So it allows you to not have to make that decision at like a cluster level anymore. And, trying to figure out if you have to do kind of over resource provisioning for different types of workloads.
Right.
So as you can see in the demo, if you want to pull it back up, I'm back to 2 nodes that I originally had. So I'm only paying for when I actually needed those nodes, and for that specific workload. So that's the flexibility, the performance, etc. I know we're like at the top of the hour here, so I can do a quick wrap up real quick if you want, Brett, and we can answer some more questions. So if you're interested in learning more and getting this set up in your environment, go to carpenter.sh. I'm positive someone's posted a link into the chat. If you don't mind putting it in there, Brett, I'd appreciate it. And if you are interested in getting involved in the open source community, helping make Carpenter better, testing it out, writing docs, writing examples, PRs are welcome. It's a great community. come join the fun. There's a Carpenter channel on the Kubernetes Slack, the CNCF Slack team, I guess you could say, the Slack environment. So come join the discussion there. One of the goals for 2022 is to reach 15 seconds for the first pod provisioning time. So if the first unscheduled pod, getting that up and running on a new node within 15 seconds. It's not quite there yet, but that's one of the goal. And to be able to do 1,000 nodes within, what did I have showing there? This is all in the roadmap. Yeah. So 1,000 pods within 30 seconds, P90 is another goal for 2022, which is, that should cover like a good amount of use cases.
Right.
I would say. So
yeah, faster than I can get a refill in my coffee. Yeah.
Oh, for sure. Feel free to hit me up. I'm at Normal Faults on Twitter. You can find me on LinkedIn. If you have any questions, hit me up, and I can help answer them. And thank you for letting me show off Carpenter today. So let's go into some questions.
So we've got at least
some questions.
I've got at least 10 questions in the queue. So
all right, I'll try.
We're going to try to make this quick. So for everyone out there, thank you so much for your questions. Thanks for being patient. We did want to get through make sure we got through the demo. So if we didn't, so some of these we may just say we already talked about that. Rewind and watch the show again or something. Just because we don't want to be another 30 minutes. Unfortunately, today both of us have other things we got to get to. All right, Kokjin says, can this be instructed to use the most cost-effective instances in both spot and on-demand modes? What about spot termination notices? So technically, two questions. So the first one is, can it be used the most cost-effective instances in spot and on-demand?
Yeah, it's going to try to do that with the Fleet API. So if you put, by default, the AWS provisioner allows for spot and on-demand instance types, like I just showed in the demo.
You just showed, yeah.
And spot obviously has cost savings there. It's going to try to find the spot instances that have the least amount of demand, so that as the highest likelihood, let me make sure I phrase this right, the highest likelihood of not being interrupted, right, which is the risk with spot instances, right? That's the trade-off there. So yes, and also the right sizing, right? So there's some other. I would encourage you to look at the Carpenter documentation and the details and what you can define in the provisioner. You can also define like CPU and memory limits, total like max for a provisioner. So I don't want to ever provision more than I don't know, a terabyte of RAM or something like that,
right? Ever.
And you can define, and that's a way you can like also limit cost or make sure that you're within what you're comfortable to actually provision and pay for.
Okay. How do instances spin up through Carpenter get tied back to infrastructure as code so that they're automatically destroyed?
All right. So this is the trade-off between declaring your infrastructure and the automation of your infrastructure, right? So both Cluster Autoscaler and Carpenter are automatically provisioning instances for you. They're not writing a Terraform, plan and then applying it to your cluster. The infrastructure as code is the provisioner YAML definition that you can store in like GitOps or Helm charts or whatever your infrastructure as code mechanism is. Like the controller for Carpenter running and the provisioners that you're deploying onto the CRD provisioners that you are providing for that cluster would be stored in your infrastructure as code. But your nodes aren't going to automatically be as configured, unless you're telling Carpenter to use like an AMI that has like a specific launch template and has your infrastructure as code stuff to do that.
Well, and that's
into that system.
Right, that's a good point. So like a lot of these tools, there's a lot of tools out there that will help create infrastructure automatically based on load or all other sorts of requirements. And historically, those things don't write back to your infrastructure as code to update them. Now that we're starting to see these GitOps tools, they are able sometimes to do that stuff. But I would argue that in this case, what we're saying is we are defining, like you're saying, we're defining this in infrastructure as code as a Kubernetes resource, the parameters, and those parameters never get changed. Like they don't need to be updated because we're not saying three nodes and then not documenting. We're documenting all of those things in the specification for the resource type, whatever it is. What is this schedule? Carpenter something? I saw like an Alpha 5 something in one of your slides. But so the point there is that that's how you define it, and then what you're basically saying is I no longer care how many exact nodes that Carpenter is managing. Like the node count, I don't need to update my IOC because my node count changed. And so I still think of this as declarative infrastructure, even though the number of nodes is different possibly at every given moment. And that's, to me, the way that one of these many ways that we're seeing infrastructure becoming less, like the OS, the number of nodes, the number of OSs is becoming less and less important as we automate and provide. To me, this is an abstraction on top of infrastructure management, right? So we're no longer having to change a template, deploy 3 more nodes, manually update, do a PR request to deploy 3 more nodes. This is doing all that per parameters, which I love. This is like, to me, this is how Kubernetes should always be. And we could always just hard set it. And there's a question on this, which this is leading me to the next question for you, which was actually answered in chat by Justin. But let me see if I can find it.
Let me make sure I read the answer so I don't say something opposite.
Yeah. I can help you with it.
There's a lot going on. Thank you for asking all these questions. I really appreciate the.
Oh, no, I can't find it.
I see some friends in there. Hi, Samil. Long time no chat.
Oh, Conrad asks, do you see Carpenter or the features of it being pushed upstream into Kubernetes? Basically, Kubernetes upstream. And Justin's reply was, that's intentionally always been left out because we don't want that we don't want to keep bundling more and more advanced, sort of opinionated functionality into the vanilla upstream Kubernetes.
Correct.
And that's like we've done that before, right? We all did that with CSIs, and now we're moving out those storage drivers when they were embedded. And I like Justin's. I don't actually have it up on screen, but he basically paraphrased.
That's a correct answer. And I think the trend, we're going the opposite direction right now, like you just said. Right now, the provider-specific implementation of certain APIs or features and functionality is starting to be removed from the Kubernetes upstream.
Yeah, because these things are not like right now. Carpenter is only AWS, and
right.
We need more community involvement in order to support other clouds or on-prem. That's one of the questions that I think is getting asked several times is about on-prem. This only supports AWS right now, right? Like it's not even a year old, if my memory serves.
Yeah, it's designed to be flexible. The only provider in there right now is AWS, but PRs are welcome.
Right.
I can't tell you what the future holds for it with respect to that.
Exactly.
It's open.
This is open source. Yep. So we're doing it out in the open, and I love that AWS is starting this because we can all hope that it's going to be a successful project in terms of having more clusters or more cloud types, rather having an on-prem version for maybe VMware. I can see the on-prem getting pretty complicated in terms of the plugin though, because now that's going to be very VM infrastructure API dependent, right?
Yeah.
I mean,
so one day there's going to be this is jokingly, there's going to be some API that gets called and, it's going to hit the hardware resellers and ship you like a new, server box or something.
I'm 6 weeks out from this pod being deployed because I need new hardware.
No,
all right. I'm going to keep going so we can get through all these questions. Okay.
Yeah.
Does it not rebound?
Hey,
oh, sorry. Does it
No
not
worries.
rebalance at all? This is Patrick. Does it not rebalance at all? Would it mean that if 24 times I only had one pod left, would it leave that expensive server up for just one pod?
Yeah, so I think you asked me the same exact question earlier this week, Brett, which is, okay, if exactly that question. Well, this is that interplay between the Kubernetes scheduler and what Carpenter's doing, right? So the question you're asking is, does the Kubernetes pod scheduler actively rebalance where pods are running based on what's going on? And by default, the answer to that question is likely no. For, there's lots of different flavors of Kubernetes out there, but just in general, it's once that pod is scheduled and running happily on that node, the Kubernetes scheduler isn't going to touch it, right? Unless something happens.
Right. This is
Now
like a do no harm default. It's like
Right.
if the pod is running, don't screw with it unless I have to.
Right.
Yeah.
Now this is like, this question gets to the heart of, like, I think probably where Carpenter and some of the scheduling, like the interplay between these two schedulers, is going to be interesting. There is a taint and toleration that you can put on a pod. So say you have a pod that's running, and it's a small little pod, but it's on a big instance because all its neighbors are gone. You can put I think it's called no execute, like some specific label and no execute. And that will immediately, like, if that node doesn't have that or if that node doesn't have that same taint, then Kubernetes is going to immediately remove that pod from that node. So there's a way to change the configuration of the pod that's already running your deployment to trigger an event for Kubernetes to do something to kind of rebalance,
to basically reprovision the pod, and then it will probably make make a decision on.
And there's other ways to do that, but that's removing a pod is going to be a destructive thing, right? Like if you have active sessions or it's like actively doing things, you're telling it to kill that pod and then reschedule it somewhere. There's no magic DRS for a pod. There might be tools out there. I'm not going to say there isn't. Maybe there's things that do that stuff.
So it's
somewhere,
not. So what you're I'm going to paraphrase what you're saying here. Is you're saying that, like, we talked about the TTL on the nodes. We talked about the some certain taints and things that you can do. So there's not a feature built in that just says, if there's only if only 10% of resources are being used, reschedule the pods to a different node. Like, that's not a feature in Carpenter today. There's capability in Kubernetes that maybe could allow for that feature, but it's not. Yeah.
So that capability could potentially both trigger the pod scheduler, and that then, because of unscheduled pod queue, can also then trigger the Carpenter scheduler.
Yeah.
Right? So,
I think that if that was likely, I mean, here's my pro tip. Like, I don't even know. I have not implemented Carpenter yet, but to me, I would just be, if I thought that was more likely, I would probably set your TTL really low, like a day or something. So that in that worst case, if we had to scale up really big and down a lot, then those big nodes would only run maximum of a day with like one pod. Because you're saying, like, if there's no pods, it might do something. If there is a pod, it won't do anything. But if the node's only going to last a day anyway, then Carpenter would just make a smaller server to replace it because there's only one pod that's unprovisioned.
And this is exactly why that's an awesome feature.
Yeah. Don't let your instances live forever. It's also just a part of all the declarative infrastructure we're learning today. Is like, the longer something lasts, the more likely it's drifted. So
correct.
Drift.
And best practice is you're likely going to have to patch things anyway, right? You're going to be upgrading versions of things. You're going to get
the next Kubernetes kubelet patch version,
whatever.
Yeah.
So it's probably best practice to do some cycling of your nodes anyway, right? And
I mean, this is kind of goes into a longer conversation around the fact that we want all of our applications that are running in Kubernetes to be able to be replaced at any time, which means, and this is something I preach about in my DockerCon talk this year and then 3 years ago in 2019, is that you need to really, before any of this can really happen, and you're talking about dynamic and spinning up and, more importantly, spinning down pods, when you're replacing them, when you're reducing the number of replicas, whatever it is, that means you have to be really good at your apps being able to handle switching pods, which means you have to deal with load balancers and time to lives on the connections. Right, TCP. Like all these things have to happen before you can auto-scale Kubernetes down. Down is the hardest. And I find that most application developers, honestly, most, don't do that. They don't dig into how exactly the TCP connections to their app are treated during a deprovisioning event of a pod. I'm going to say that out loud because maybe all of you listening are amazing developers. You probably are. But there's a lot of people I work with that they just kind of hand wave around it, even if it's HTTP, and they don't really think about the fact that, well, what if the user's uploading a video or an image to your platform that's 10 meg size image, and they're uploading it over dial-up or whatever, or over mobile, and it's really slow, and you deprovision that pod, you drain the node, and the pod just kills itself because it's been given a SIGINT, and it just doesn't know how to hold on for connections. So this is very much an application developer problem as much as it is an infrastructure problem. It's not a problem until you realize you got customer complaints every time you do a rolling update of your pods, and you're like, okay, maybe we need to handle scaling down better. Anyway, sorry, soapbox moment for me, because it's not always infrastructure that's the problem here. It's a lot of times it's the apps that can't deprovision well. So, all right, sorry, we're 20 minutes in. I'm gonna cherry pick a couple of these questions that we maybe have not covered. Raman asks, can horizontal pod autoscaler trigger Carpenter?
Yes, and I think there's already an answer from Justin. So if HPA, so the horizontal pod autoscaler is looking at the resources being used by a pod or a collection of pods and creating more pods of that type based off of that, right? So it's scaling out number of pods for that. HPA can trigger Carpenter because if HPA starts to say, I need 100 more of this pod, and there's not space for 100 more, then it's just like what I showed in the demo. Carpenter is going to provision more nodes for that HPA scaling event. Right.
So indirectly, it does, but it doesn't need to connect to that API or whatever because of the scheduler and the fact that the Kubernetes scheduler is handling this itself. Right. So
there's a symbiotic relationship. Right.
And that's a good point. If you're going to do node auto scaling, you are probably at the level of someone who's probably considering horizontal and possibly even vertical pod auto scaling as well, because the Carpenter only solves part of the equation, like you explained earlier. So if you're just now joining us, go all the way back in the video or come back later when it's over, and you can watch all the slides that have the great diagrams. I love those diagrams because it very much explains the different problems that different auto-scaling tools solve. Carpenter doesn't solve them all. It tries to focus on a specific one. All right, Maximum, I saw your questions. Sorry if you're still hanging around. I feel like we've talked about cluster destruction, pod destruction, all these different things, scaling down.
Showed that.
We've talked about that. So we're gonna assume that's answered. Is there a reference? Okay, so Conrad's asking about documentation for adding functionality to Carpenter for other types of Kubernetes environments. So the question is, are there developer specs and documentation for people to be able to, is it in the docs, basically?
Yes. Yeah. So there's, I would say go to the GitHub for Carpenter. Let me see if I can find the chat window real quick. Did you already put that in here somewhere?
I put Carpenter and the AWS GitHub repos in.
Okay. Yeah, so I would suggest you go there. There is documentation and specs, and then also join the Carpenter Slack channel on the Kubernetes Slack.
Yes. So ask in Slack or ask Nirmal on his little Twitter handle there. In case you can't find it, he'll answer you later.
I'll help you find that.
So for Chang, I'm sorry if I mispronounced your name. The instance size, we already covered this. If you watch back to the video, the question here was, how does it determine which instance size to pick? That's it basically right sizes, it batches, it does all those things.
I
Does it-
think this is I think this is my friend Tom. Nice to see you, Tom, on the chat. So
Hey, Tom.
how does it? Hey, Tom. How does it pick the instance size? I talked about it a little bit briefly, but and Justin, it looks like he answered your question as well. But it hits what's called the EC2 Fleet API, and I can send you more information on that, which sends an array back of instance types that best match the resource requests that you send that API. So there's a awesome API that Carpenter uses to figure out what the right instance size is, on top of taints tolerations, labels, and all the other things, right? So it kind of follows the same pattern as, not the same pattern, but kind of matches the pattern over the pod scheduler, which has 2 steps, right? Filtering and scoring. It's kind of like that, if you will, right? So it filters what options are there based on the API call, and then it picks the right size one that best matches the resources.
All right. A similar question from Martin: does Carpenter respect the desire to spread workloads across AZs?
It can. So I think in the presentation I showed a provisioner that had different availability zones, and if you want to scroll back or rewind in this video at some later date. You already have it
right
pulled
there.
up. Awesome. Thank you. So you can specify different availability zones.
Yep.
You can, there's affinity, anti-affinity patterns that it's going to, if you put that on a pod, deployment spec, it's going to follow all that stuff. So yes, I think we're just at the beginning stages of the really cool architectural patterns that one can do with this kind of tool.
Right. Rather than doing it home, rather than having to solve it with their own custom automation or wrappers, you can just define it in the spec, and hopefully will be flexible enough for all the edge cases. All right. EKS Anywhere. Xing is asking again about EKS Anywhere support. I believe Justin said not yet.
No. So yeah, EKSA doesn't support autoscaling yet. So for that, we recommend using infrastructure as code techniques to scale out your infrastructure, like, Terraform or GitOps, or, probably GitOps if, and I know Tom knows GitOps. So GitOps is probably the best way to do EKSA.
And last question.
Awesome.
I think it's the last question. Sorry if I missed anyone's questions. I tried hard to,
yeah.
And how do you pick AMIs? Is that part of the,
Yeah, so that's part of the provisioner. You can specify, the AMI that you want. You can also do Bottle Rocket, which we encourage folks to use. Bottle Rocket is a awesome, optimized, very performant operating system, if you will, an AMI that's really great for running Kubernetes workloads. And so that can be provisioned. It could provision your custom AMIs, things like that.
Yeah. I will make this last comment on behalf of Hemant. I've been using Carpenter in production with spot instances and replaced node groups with it. Saved almost 80% of our cost. So there you go.
Hey, Mantha, if you don't mind pinging me on the Twitter or getting in touch with me, I'd love to know more about how you did that.
Yeah.
So if you don't mind hitting me up.
AWS wants to talk to you. So
yeah, that sounds awesome. And that's
get in touch. Yeah.
That's the kind of things that we want people to use it for, right? We want to make sure that your experience using Kubernetes is right sized and performant and available.
Well, you heard it here, people. Carpenter, check it out if you're on AWS. If you're not on AWS with your Kubernetes cluster, you can still get involved with the project and help make it better, maybe for your cloud. And I hope that this really catches on, because I like automation and easy tools that there's not too much magic. And I love how you explained it. It's not replacing the scheduler. It's simply augmenting. It's doing things that are sort of exactly what Kubernetes add-ons or controllers are designed to do to add this kind of functionality. It's not in any way hackish or these 5 steps are needed before this works. It seems like it's something that's really easy to implement per Kubernetes standards. So I mean, not that I give ratings on stuff. Maybe I should start doing that. You know how like I gave it 3 thumbs up or whatever. But this is the kind of tool that I would instantly want to look at and recommend to my clients and customers that are on AWS, EKS, that kind of thing. So I look forward to hearing progress about this project because it's still relatively new, right? Like I think it was less than a year ago it was announced. So it's great that it's got so much functionality out of the box already. So I'm looking forward to seeing what the future holds. And you're saying that one of the goals for this year on the roadmap, and it's cool that it has a roadmap, is super fast in really increasing the instance spin up time, which historically for Kubernetes in the cloud in general has always been a challenge. So I'm always excited to hear progress on that.
Yeah, and if we didn't get to your question, feel free to hit me up through the socials or other channels. And I think what is my name? My handle's right
down there.
It's really easy to find me. So hit me up and let me know what questions you have. And if you like it, shoot me a note too. If you don't like it, let me know why. And also, I put a link to our EKS newsletter. So if you want to know, if you want to keep up to date with EKS and Kubernetes coolness, subscribe to the newsletter. Comes out every week.
Nice. And I will put a link to that in the show notes for those. Now, if you remember, everyone, this becomes a podcast probably about a month or so from now. It'll become a podcast episode. So again, sign up for the Patreon link below or one of these links above. We'll all send you the Patreon, and you can get my free, about once a week email about what's on the podcast this week, what's on the live show this week, what open source is coming out. And thank you all for being patrons. I know some of you are out there, and we will be back here next week. So coming up next week, sadly, not more Nirmal yet. He will be back. He's always invited back. He'll be back at least a couple times a year. We got Perry from Docker next week. We're going to talk about Docker extensions, building your own Docker extension for the brand new Docker desktop extensions thing that is just like every month now there's like new Docker extensions all year long, even though it was pre-beta before DockerCon. But I'm super excited about that stuff. So we're going to learn next week how to make one and from the team itself. And then after that, we're having Replicated. Mark Campbell, one of the co-founders of Replicated on the show, a project that I got to work with last year on basically using Kubernetes for commercial off-the-shelf software. So if you're a software vendor, a traditional software vendor, and you think you need to distribute your software to your customers and you want them to run it on Kubernetes, Replicated is, I think, the best solution out there for that. So we're going to have them on the show to go through all the new open source they have, all their products, mostly open source. And then we've got Aqua Security coming up. Ani East is going to be on the show. We're talking about Aqua Security and Trivy and all their open source. So a lot of stuff coming. Stay tuned every Thursday here on YouTube Live. Thanks again, Nirmal. See y'all next week.
Thank you so much, Bret. Bye.